Alright, hi. We are going to talk about geometric sequences from the beginning here and just give you an overview of them because a lot of students have been asking me about this, so let's go ahead and get started. Okay, so first of all, before we talk about what a geometric sequence is, let's define just what a sequence is. So, what is a sequence? Okay, a sequence is just a list of numbers that follow a pattern. Okay? So we've seen lots of sequences. Anything that follows a pattern. So I could say 2, 4, 6, 8, 10, 12, 14, 16. That would be a sequence of numbers. I could go on forever and ever and they follow a pattern. Or the counting numbers, 1, 2, 3, 4, 5, 6. They follow a pattern. They go on forever and ever. That's another thing that's important about a sequence. The list goes on forever. Okay, I gave two examples of sequences, but neither of them were geometric sequences. So now let's talk about what a geometric sequence is. A geometric sequence has what we call a common ratio. I'm going to write this in a new color so that it seems important, because it is. Has a common ratio. So it doesn't just follow any pattern, but it follows a pattern that uses multiplication. And let's take a look at an example of that. Okay, we're going to actually build our own geometric sequence. So, we know that there are going to be a bunch of terms, in fact an infinite amount of terms. Let's just draw some spaces here. And then I'm going to draw dot, 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 meaning that this list goes on forever. There are an infinite amount of numbers in it. Okay, so we also call each of these terms a specific thing. And this may be something new that you haven't seen before. The first term, instead of saying the first term or having to write that every time, we could just say A and then sub 1. This means the first term in the sequence, and we know that because of the little 1 that's underneath the A. The second one is called A sub 2, the third would be A sub 3, A sub 4, A sub 5 here, A sub 6, 7, 8, and on and on and on, all the way to infinity. Now since we're building our own geometric sequence, we get to choose what number we're going to start with. So, let's see here. Let's get a nice red color, reddish, we'll see how red it is, for our first number, for the numbers in our sequence. In fact, we'll use all the same color. And I think we could start out with the number, let's start out with the number 24. Now, because we're the ones building this geometric sequence, we can also choose what our common ratio is. So, let's choose our common ratio that we call R. So I'll put that in parentheses up here. To be equal to 1 half. That means that to get from the first term in the sequence to the second term, we're going to multiply by the common ratio. So 24 times 1/2 is equal to 12. Now to get the third term in the sequence, we take the second one and times it by 1/2. So the third term will be 6. To get the fourth term in the sequence, we times the third one by 1/2. Which leaves us 3. And to get the fifth term and the last spot that I kept in the list, we times the fourth number by 1/2. We get 3/2. So the thing about the common ratio is that it's the number that we use to multiply by every single time. Every time. Or it wouldn't be a geometric sequence. But that's the pattern behind it. All these numbers, we can predict the next one by multiplying by 1/2 or by the common ratio. Okay. Now, let's do a problem where we're given a geometric sequence where we're not building it, and we're asked to find what the common ratio is. We'll do a couple of examples like that. So let's clear this screen. Okay. So if I go example, here, and we're told to find R, and I've put this in parentheses now, that's the common ratio. Okay, so if our sequence looks like this, if I choose our first term, or a sub 1, to equal 11, and our next one to equal 22, we'll say our next one equals 44, and then 88, and that's all the terms we'll say that they give us. Then we get the dot dot dot. So what does R equal? What number are we multiplying by each time here? To get from 11 to 22, what did we have to multiply by? To get from 22 to 44, what do we need to multiply by? And to get from 44 to 88, what are we multiplying by? It's all the same number, which means it is a geometric sequence, and we're multiplying by 2. That's a pretty easy one, isn't it? If we double 11, then we get 22. 11 times 2 equals 22. 22 times 2 equals 44, and 44 times 2 equals 88. So we know that our common ratio is 2 here. Okay, let's try another example. That's a little bit more difficult because we're progressing. And I'm going to say find R. This time we'll start out with let's see here, 27. My next term we'll put as 9. My next term will be 3. And then the fourth term will be 1. Oops. I just want it to be 1, comma dot dot dot. So to find R, we need to realize what we're multiplying by to get the next term each time. Now this one isn't as obvious, so I'm going to teach you something you can do to always get the common ratio. There's a little formula. It was pretty easy to see up above that we were just doubling, which means timesing by 2. This one here, though, isn't as obvious. To get from 27 to 9, it's kind of hard to think, what did I multiply by? So maybe you know already, but just in case, I'm going to give you a formula. And we'll put this formula in our red color. The formula goes like this. The second term, or a sub 2 as we call it, divided by the first term, or a sub 1, is equal to the common ratio, or r. So that means that I can take this second term, which is 9, and in this case the first term is 27, and so if I take 9 divided by 27, I'll get our common ratio. Let's go ahead and do that. If I go 9 divided by 27, this is going to equal a common ratio. Well, 9 goes into 9 once, and 9 goes into 27 3 times, so it looks like 1/3 is the reduced version of our common ratio. Now, if you're unsure about where I plugged things in, I'll show you here. Let's do this in yellow. I took our second term here, and I plugged it in on top for a sub 2. And then I took our first term here, and I plugged it in at the bottom for a sub 1. That's how I got 9 over 27. Our common ratio here is 1/3. If we multiply each of these by 1/3, then we get the next number. Like 3 times 1/3 is equal to 1. Okay, we're going to do one more type of problem, and then I feel like you'll have a good background with geometric sequences. Okay, what if we had a problem that said this? Find the 5th, 6th, and 7th terms in the following sequence. Okay, so I'll give us just the first 4 terms. So let's go like this. We're going to start out with 2, and then we'll get 3, and then we'll get 9 halves, and our 4th term will be 27 fourths, comma dot dot dot. Now remember, our 5th, 6th, and 7th terms will just be the next 3 in this sequence, because we have here a sub 1, a sub 2, this is a sub 3, a sub 4. So we're looking for, we want a sub 5, a sub 6, and a sub 7. The 5th, 6th, and 7th terms. Okay, well, our first chore is to find what the common ratio is. Because once we have the common ratio r, we can just use that and multiply the 4th term by r to get the 5th term. And then we can multiply again by r to get the 6th, and again to get the 7th. But the key is knowing what the common ratio is. So let's use our formula. Remember, I'll put a little star here, that a sub 2 divided by a sub 1 is equal to r. So in this case, we're going to take 3 and divide it by 2 to get our common ratio. So in this case, 3 divided by 2 is equal to r, or r is equal to 3 halves. Now we can use 3 halves and multiply that by 27 fourths, or the 4th term, to get the 5th term. So let's do that now. We know that a sub 5 is going to be equal to the 4th term, 27 fourths, times the common ratio, 3 halves. This is going to be equal to 81 over 8. So check, that's the 5th term in the sequence. We've got it.